Hi, welcome to an audio test session with APX. These videos provide worthwhile information for APX users and demonstrations on a range of audio measurement applications. In this session, Eric introduces the APX500 software.
This video is an introduction to APX500 measurement software. I'll show you the two modes of operation, bench mode and sequence mode. We'll look at the navigator, the measurement configuration pane, the results pane, monitors, meters, and status bar, as well as the menu and toolbars. We'll also cover the main concepts of setting up your signal path, adding measurements and results to your sequence, running the sequence, and generating a report of the results. I'll also show you some tips and shortcuts along the way. When you start APX500, it searches for a connected APX analyzer. If none are found, the software will start in demo mode and prompt you for the analyzer model to emulate. Just select one from the menu here. I'm connected to APX515 hardware, so no demo mode options are displayed. When APX hardware is detected, its firmware will automatically be updated from the PC if necessary. The software version is visible here, and more details of the software and connected hardware components are available here in Help About. This is the mode selection toggle switch. Sequence mode is the original mode of operation. It has a built-in test sequencer and reporting engine. It's well suited for validation, production test, or any time a measurement or group of measurements must be repeated. Bench mode was added to APX500 in the version 4 software release. Bench mode is more of a free-form paradigm favored for research and development. Bench mode provides more user control, but no sequencing features and fewer measurement types. I'm switching back to sequence mode for the remainder of this video. In sequence mode, the main components are the navigator, the configuration pane, the results pane, the film strip, the data sets panel, the monitors and meters, the status bar, the menu bar, and the toolbars. Let's take a closer look at each component. The navigator displays your sequence, which is a list of signal paths, measurements, and results that will be executed from top to bottom when the sequence is run, thus automating the test system. The hierarchy is the APX500 project file, sequences, signal paths, measurements, and results. An APX project may contain multiple sequences, executing multiple signal paths, each with their own settings, measurements, and results. Selecting a measurement in the navigator displays its properties in the configuration pane, where you can adjust the settings. You have controls for the generator and the analyzer. The Advanced Settings button reveals additional control for signal generation, acquisition, and analysis. Here's an important shortcut you'll often use. The left-facing Go Back arrow button here at the top of the configuration pane will toggle between the signal path setup and the current or last touched measurement. This is super handy when adjusting and fine-tuning your signal path and measurements. The signal path setup is a special measurement with a collection of settings, controls, and results. Signal path setup is always the first measurement in every signal path. Here we have the output configuration, where you select the connector to be used. I'm using analog unbalanced 2 channels for my stereo amplifier, which is connected as the device under test in this video. Additional settings for the selected connector are accessed here. An EQ correction curve may be applied to the outputs here. The input configuration allows for 1 analog input and 1 digital input to be configured and measured simultaneously. I'm only using 1, analog balanced 2 channels. We have high pass, low pass, and weighting filters, as well as a bandwidth setting and input EQ. Loopback provides an internal connection directly from the generator to the analyzer, bypassing the device under test and cables connected to your APX. Verify Connections provides generator controls. These are handy tools when checking your physical connections and software settings. We also have references, output and input for analog, digital, and acoustic configurations, settings for optional output and input switchers, control of the optional DCX module, as well as clocks and triggers on applicable APX analyzer hardware. All windows with the undock arrow are undockable. Clicking the X to close the new window puts it back. The Results pane displays measurement results, meter readings, and XY result graphs. Right-clicking in the graph pops up a menu with tools including zoom, annotation, and assignable cursors. The film strip provides one method to select which result is displayed in the Results pane. You can also select the result to display in the navigator. The Datasets panel shows measured and imported data sets with the date and time of acquisition. There's also a field to add notes. This is the Monitors and Meters window. When turned on, they update continuously. We have scope, FFT, meters, auxiliary I/O, status bits, HDMI, Bluetooth, PDM, and clock monitors. You can undock each monitor, and some provide additional controls. Here's a tip. Turning the monitors off when not needed will improve performance in the GUI when working with large channel counts and high bandwidth audio data. The menu bar provides file functions, view options, measurement access, project properties, window selections, and system help. Click the F1 key to display help on the currently selected item. The toolbars located at the top of most windows and panes provide one-click access to often used tools. And lastly, the status bar shows the current output and input connection status. These are continuously updating. Now, I'll show the sequencer in operation. First, I'll use the automatically set generator level feature to find the level where my amplifier makes 1% distortion and set that level as the generator reference, also known as 0 dBRG. As you may have noticed, the default APX project file contains the basic 6 audio measurements: level and gain, THD plus N, frequency response, signal-to-noise ratio, crosstalk, and phase. I'm going to enable all of them. When measurements and results are enabled, they'll be executed as the sequence runs. Level and gain is first. I'll set the level to 0 dB RG and turn on the generator. Now I'll add limits. I can right-click in the Results pane and select Draw Limits. I'll add upper and lower limits. Total harmonic distortion and noise is next. You can view distortion plus noise, distortion only, noise only, or the distortion products individually. I'll add limits to THD plus N ratio. Frequency response uses a chirp signal, which is a hallmark measurement in APX. It's very fast. 350 milliseconds is the default sweep time. I'll set the level and turn on the audible monitor so you can hear the chirp signal when I start the sweep. Now I can use the acquired data to make limits. If I select Edit Limits, then Import Copy Data, and select From Graph, I'll use 30 points applied to upper and lower, then offset the upper limit by 1 dB and the lower limit by -1 dB. If I change the generator level, so -3 dB, I can show you how the limit failure looks. I'll enable Append Graph Data so we can see two data sets at once. You can see the fail indicators here and below in the film strip. I'll leave the generator at -3 dB so this result fails when we run the test sequence, and we'll see the fail indicator in the navigator and on the report as well. The next measurement, signal-to-noise ratio, is actually two measurements. The first measures full signal level, then the generator is turned off, and the second measurement is of the noise floor. The displayed result is the ratio between the two measurements. We'll add limits here as well. Next up is the crosstalk measurement. Crosstalk is the amount of signal leakage between audio channels. In other words, how much of the signal input to channel 1 of the DUT is output on channel 2 of the DUT. I'll add limits here as well. Our last measurement is interchannel phase. This displays the phase difference between channels. Note that one channel is the reference while the other is measured. I'll click one of the Add Measurement icons and select interchannel phase. I'll set the second phase measurement using channel 2 as the reference. Now that our signal path and measurements are configured, we're ready to run this sequence. When I click the Sequence Start button here, the sequence runs all enabled measurements and results from top to bottom. When each is completed, a green pass or red fail indicator is displayed, and at the end of the sequence, a results report is generated and displayed. We can see the pass fail indicators, the signal path setup information, all the meter results, and the graph results. You can export the report to PDF, HTML, RTF, XLSX, CSV, or MATLAB format. You can also edit or customize the report with title, notes, display options, your company logo, and you can set up auto-naming and auto-saving the report file. This concludes our APX500 measurement software introduction.
Thank you for joining us for this audio test session with APX. For additional videos, visit ap.com or any of our social media channels.